Now, if we have the point x1, y1 and the point x2, y2, we can do the same thing we did before. We can throw in a point xy out here and then write down the condition for the point xy to actually be on the line through the first 2 points. So we write down, we sketch, construct our fundamental triangles between x1, y1 and x2, y2. The rise is clearly y-coordinate, difference of the y-coordinates, y2 minus y1. The run is x2 minus x1, the difference of the x-coordinates. On this triangle, the rise is difference of the y-coordinates, y minus y2. Difference of the x-coordinates, x minus x2. So there's the run, there's the rise. xy is going to be on this line through x1, y1, and x2, y2 if and only if the two slopes are equal. Well, what are the two slopes? Y minus y2 over x minus x2. That's the slope of the second triangle. And the first is y2 minus y1 over x2 minus x1. Now, this will work. If you have the coordinates of these 2 points, then you'll have numbers to put in for everything here except the y and the x. And then, of course, this ends up looking just like it did before. Okay, well, we want to solve this for y. Now, the solution gets kind of complicated. We're really better off just writing this down and proceeding from here. So I will say that right there is the equation. We usually wouldn't solve this equation symbolically, but I've gone ahead and done that. Multiplying through by x minus x2, then distributing here, and then adding y2 to both sides, and I shouldn't have had the y2 over here because I've added it to both sides and gotten a y2 over here. So let's just obliterate that to the extent that I've been able to do so. And there's our solution. Okay, now that isn't really necessary because this form suffices. I can also say that, well, I could have equally well done a fundamental triangle from xy to x1, y1. I didn't have to do it to x2, y2. There's no specific order for where x1 is and where y1 is. Where we put xy might well be closer to where x1, y1 is. Not that that makes any difference. The point is that if xy is on the line, then the slope from x1, y1 to xy has to equal the slope from x1, y1 to x2, y2. So we can say the slope from x1, y1 to xy is also equal to y2 minus y1 over x2 minus x1, because again, the slope between any 2 points of a straight line is the same as the slope between any other 2 points. That tells us then that, well, the slope from x1, y1 to xy is going to be y minus y1 divided by x minus x1. That's going to equal y2 minus y1 over x2 minus x1, and we end up with the same solution. And really all we've done here is we've replaced x1 and y1. Well, we've replaced x2 and y2 by x1 and y1, because that has to work, because it really doesn't matter which point we call x1, y1 and which we call x2, y2. I could reverse the labeling of these points and get this. So for many reasons, it's identically the same. And I'll note that I've got x1, y1 here. Well, that doesn't matter. Okay, I'm going to leave it at that. Forget what I just did.